So the first thing we do is simplify. When we simplify, we always, if we see distribution, we do that first. What do we do after distribution? Olivia, what do we do after we distribute?
Combine like terms.
Yeah, if you can. Sometimes you won't be able to. Always, 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 the distribution comes first, and then combine like terms. We did this last week. We did it 2 weeks ago. That shouldn't be new. Then we are going to isolate. That's the part that's new. Okay, if we're going to isolate, what I mean by that is that you are going to either, so I'll put a little dash. This means to add, not slash, add or subtract to get variables on same side. You have to add or subtract to get your variables on the same side. Next thing is solve. That shouldn't be new. When we solve, you're going to see me write it like this a lot. So we do PEMDAS backwards. That shouldn't be new. But when we're doing order of operations backwards, what we're really doing is the first thing we're doing is probably adding or subtracting. And then we're either going to multiply or divide. Whenever we solve equations, we want to draw that line down the equal sign, so we make sure we keep our sides separate so we don't mix things up and accidentally combine like terms with things that aren't on the same side. So it's like a brick wall. Make your brick wall. Let's start at the very top of our steps. The first thing we're told to do is simplify. Alice, do you see any distribution? No. Yay. No distribution. So, done. You could cross that out if you want. Do you see, think about this in your head, do you see like terms in your head, in your head? Don't say it yet.
Yes.
Who sees like terms? Raise your hand. Oh, no. We talked about this last week. If they're on different sides, you can't combine them. Right now, they're on opposite sides of the wall. You can't just poof combine them because there's a brick wall between them. So no is what I'd say there's no like terms because you're looking at 3x. 3x doesn't have any friends over there. 7x minus 12. Those aren't like terms, so you're done. So there's no simplifying we can do here. But you can, hold on, you can isolate. You're trying to get the variables on one side, on the same side. You have 3x on the left and 7x on the right. They're friends. They want to be together. So we're trying to get them together. But if I'm going to move something to the other side, do you remember what we have to do, what the thing is when we do the opposite? What's that called? The inverse? We have to do the inverse. We have to do the opposite to get it over. So what I'm going to do, so I'm trying to isolate, so I'm going to write an I out to the side. I'm going to get 3x and 7x together, but I can't just combine them because they're not like terms, but they are friends. So what I'm going to do is subtract 7x from both sides. Could someone please explain to me why am I subtracting and not adding? Raise your hand. Why do I subtract? Tyler?
Because it's in very low.
Kind of. I am trying to get them on the same side, so the same variable and they're friends. Why am I subtracting?
Because at first it's a positive number.
Oh! it's a positive 7x. So if I want to move it to the other side, then I have to do the opposite. So you could like make a note. Do the opposite. So I subtract 7x because it was positive 7x. 7x minus 7x is what? 0. So you get to cross that out because we're moving it to the other side. So now we need to rewrite our equation. If I have 3x's minus 7x's, and I have negative 4x's. So I say negative 4x equals negative 12. So now, here's why this is good, because now there's only variables on one side. That's what we want. We moved the 7x over by doing, moved this way. 7x over by doing the opposite. Now it's an equation we know how to solve because there's only variables on one side. That negative 4 is being multiplied, so you do the inverse. So this is s. And divide by negative 4. Negative 4 divided by negative 4 is 1, so you get to cross it out. Let's draw a new line. Negative 12 divided by negative 4 is 3. How about Elise? What's the first thing I should look for?
Distribution.
Do you see any distribution, Elise? No. I don't see any distribution. I look on the left, don't see any. Look on the right, don't see any. We're good. How about after that? George, what am I looking for after I just look for distribution? Okay, do you see any like terms on the left? No? Do you see any on the right? No. So you're done. There's nothing to simplify. Sebastian, if I have nothing to simplify, then what do I move on to next? No. Isolation, which means to add or subtract to get the variables on one side. I'm going to move one of these things. Sebastian, do you want to move the 2x or the 4x?
2x?
I would probably say that's probably a good idea, because if I move the 4x, I'm going to end up with a negative. So let's move the 2x. So there's nothing to simplify, so we're going to isolate. It's a positive 2x. So how do I get rid of it, class?
Negative 2x.
Positive. What's the operation? Add or subtract? Subtract. It's positive, so you have to subtract it to move it. So minus 2x. Make sure you write the x. Don't forget it. We're not moving 2, we're moving 2x. Because these guys are friends and they want to be on the same side. The 2x minus 2x goes to 0, so you get to cross it out. And then rewrite 4x minus 2x would be 2x. Just subtract the numbers, keep your variable.
12.
And then plus 12, bring that down, is equal to 24. This is a two-step equation. You should know how to solve it. So I'm going to subtract 12 first, because I add or subtract first. Oh, I'm solving now, s. So subtract 12 from both sides, add or subtract, rewrite 2x equals 24 minus 12, which is 12, and then divide by 2. So the last thing we always do is multiply or divide. X is equal to 6. If I want to find the perimeter, I add up all the sides. Problem is we only know what 2 of the side lengths are. So we're going to have to figure out what x is and then plug back in and figure out my side lengths. This is similar to the problem you saw last week on your notes in your quiz. So the first thing I'm going to do is figure out x. We know that opposite sides of rectangles have the same length. So I'm going to say that these two sides are equal. So 2x is equal to 4x minus 14. Because those side lengths are the same length. Now we get to solve for x, our balancing line. Do I see any distribution, guys? Any, look on the left-hand side, do you see any like terms? No, there's only a 2x, that's it. Look on the right, do you see any like terms? No, 4x and negative 14 are not the same. No like terms. It's okay. But, Joanne, what you can do is isolate, because I know we have 2x and 4x. We want to get them together. So, Joanne, what should I do? Oh. Joanne, what should I do to get them on the same side? Yes, subtract 4x. So I end up with negative 2x is equal to negative 14. Divide by negative 2. And I get x equals positive 7. So I isolated and then solved. In case you haven't picked up on it, the ones that you're going to see today are they're not going to have any simplification. So what I can do now is say, instead of writing x up here, I'm going to write 2 times 7. Because 2x is 2 times x. So that side length would be 14. Which means the side length on the bottom is 14. To find the perimeter, we add up all the sides.
28.
So 14 plus 14 plus 7 plus 7.
Oh, 42. Another 14.
What would that be?
42.
42.